Hello hackers, welcome back to Rust for Hacker series. This is going to be the 11th episode of the series, and if you've been with me, you know we did a lot of coding in different sections of Rust, and we are improving step by step. We did cover a lot in web application related security and other sides like basic normal Rust, and we did develop project related security using the basics too. And now it's the time to jump a step further. Today onwards we will be focusing on network side of Rust, network programming, and how can we make tools that help us to learn Rust networking, plus how we can make use of those tools in real-time cybersecurity engagements. And today's project is going to be a reversal. A reversal, by definition, if you ask me, technically is a network application that has two parts, a controller and an agent. Agent normally connects back to the controller. When we create a reversal, we create an agent that is pre-configured with the attacker's IP and port. So whenever that application runs, it connects back to the attacker's IP to the specified port. Then the attacker can execute commands on the remote machine using his controller. That's definition if you ask me. I have one presentation with me. Yeah, it works something like this. When a victim machine suppose if the hacker did some trick to make the victim to run his binary using some social engineering techniques, then this application will execute it on the victim machine. The actual application, what it does is it just tries to connect back to the attacker machine on a specified pre-configured port. Then once it's get connected, the attacker can completely take control of the remote machine. And there are some other complications apart from the normal connectivity, like maybe in a corporate environment there will be some other tools, but we are just considering only the basic stuff because our more focus is going to be on Rust and how easy or how difficult it's going to be to develop a reversal using Rust. So this is a way it works, and if you are into security, you know, or I know you already might have used this reversal so many times for different purposes. So let's focus into our program now. So what we are going to do is we are going to develop an agent first, then we try to use the famous netcat as our listener. Then once if an agent is working well, then we move to the listener. So let's start with the project. I'm going to create a new project called TCP agent or something. Okay, it's created. So let us open our IDE. So for creating, actually I did this project 3 years or 2 years before when I started Rust programming. So you can see that in my GitHub project. If you are interested, you can I think it's here. Not exactly here. Okay, I will show that source code I did. Anyway, I'm going to take the code and I'm going to make some changes to that. So let's start from the scratch. That will help me to learn more about that. So we are going to do the same thing, and for this we need a TCP stream that is going to connect to the attacker machine. So once the attacker machine and when I'm saying attacker machine means we need to specify a port and an IP. So once we get connect to that, we get a network stream, and we have to process that stream for a consistent connection. for that we need to make use of some packages. The first one will be the net package that has a TCP stream. We are going to make use of TCP stream here. See, it's suggesting other stuffs with this. Yeah, I need the stdio one, but I need not these two, but I may need the buff read, and maybe buff reader I need, and of course I may need the write. So this one suggested by the A, but I don't want that now. But definitely the other one I need is we need to make run commands in this agents, so we need this process and command. So for the time being, let's start with that, and let's start app. Wait, it is suggesting so many things. Let mute stream, and yeah, it is the TCP stream that we are going to make use, and the connect user method. So we have to mention your IP. For the time being, for the testing, I'm just using my local IP here, and instead of unwrap, it's always try to, yeah, this is a perfect message. It's really good here, but it's not that much. Okay, this is correct. Now we have the stream, the TCP stream I have. Now definitely I need a loop that should be going to make use of this stream. The next thing I need, I have to read this, I have to make the stream I need to get the command from the controller using this stream. For that, I'm going to make use of a method called buff reader that will help us to get this stream into the buff reader. Then later we can read it, read from the buffer reader. We can read the command that the server sends, the controller sends to us. So for that, let us define a reader. Yeah, we can. Yeah, this is a correct syntax. We now have a buffer reader with a TCP stream. Now we need the next thing we need is we need to read from the reader. We need the actual aim of the next state. The next thing is we have to get the command that the server controller sends to us. So we need a method that help us to read. I think read until is the command we have to use of. See, it accepts a byte value, like till what could be the what to say, till how can I explain that? We have to get the command from the controller in a way that when the attacker sends a command, he enters the command name and press enter. So we need that, so we have to read till until the new line. So what we can do is this is a way we have to mention that here b means is a byte value, and till it sees a new line, it's going to read from actually it needs another mute vector. Actually the second parameter is a vector, so we need another vector. So let it be here. Let mute and say server. Server input or maybe we can make it as our CMD, and I think this one was expecting a vector of U8. That was it shown here, I think. Yeah, vector of U8. So it's nothing but vector of bytes in a way. So I have that here. So the second parameter what I'm going to give is, I'm just going to give address of, it's a mutable variable. Then I'm saying that read until this one, and what is this? Actually it is it is returning a result value. So what we can say here is expect some message, command read error from server, something like this. What was the mistake here? Syntax or expect a semicolon. Did I make some mistake? Oh, sorry, I missed this one. This is syntax. So I created a reader. So as the reader has a value, cannot mutate. Now it says the mutable value is not acceptable. Oh, this should be a mute, because we are changing values here. So reader should be mutable value. So the next thing that we are going to do is we have the command from the server. So what we have as like a byte vector. So we have to convert this to a string. Yeah. Oh, I should have taken that. Like, this was a correct sentence suggested by the AI. Now we got the command, and yes, from UTF-8 we got the actual string. So now we have the string but we need the exact result. So this is better. Like, now it is a string, and try to print it here for the time being. Print. Let this be the command. Now we have the command. Now the next thing is we have to execute the command on the machine. So for that we have to use the process command package. For that, what we can do is okay, let it be, okay, we can make it in a way like there's an effective usage if let actually help us. Suppose anyway, what we are going to do is, like, we have to take the command output from the, what to say, after running the command on this machine. So it suggested something, make output. Yeah, for the time being, just consider this. That's going to be the thing that we need. And let me take everything that is suggesting. Okay, what it suggested, let us see. So it's nothing but it's trying to run. Okay, another thing is no, there are some things that you need to consider when you are on an attacker perspective. Normally when you use bash things, normally it gets logged, but bin as such, sometimes it escapes from the logging. So for a safer side, I always suggest to use bin sh instead of the normal bash. I think it is showing here. Was it that? Oh, it was not an but server side. Why it is not giving? Is it? Is it returning? What is a convert slice byte into string loading? Okay, let it be like this. Let us see how it works. So now we have okay, we have to take this one also. Now we have the output. Now we fetch the command from the server side, controller side, and now we have run the command using command new and the program name. Then the arguments, the first argument I'm using is -c, and after that I'm just sending the actual command. So then after that I'm just saying output. So I'm going to fetch the output from this the command. Then okay, what exactly this one suggested by this? Yeah, actually, when we are getting the output, the output has definitely has std out and error, because we are running a shell command, so we have to redirect that output and error to our controller. So then only we will come to know what exactly happened. So for the time being, what I'm doing is I'm just taking the value. Yeah, it suggests ask for this suggestion. Just say to string. I don't know why it didn't suggest to string here. That was strange. It should be to string. Because we need the string value of std out and error. So yeah, we are trying to do the both here, out and error. Then we use a method called write all that will help us to write everything back to our server stream, controller stream in fact. So basically this will but instead of it's always try to make use of the expect method, because when it gets panicked, at least on runtime you will come to know what exactly happened. So here we are writing both as bytes back to the controller. So if you ask me, yeah, this is going to be a basic reversal. Let us see how it works. So for testing this one we need okay, let me open another terminal and say get is not there, so we'll see -lvp. I'm making my listener, like it's this listener is available for almost every security related distros, and normally apt-get comes with nmap in Windows machines. If it's not here, definitely I can install that too, but let us try with the normal netcat available. Netcat is nothing but it's a listener kind of application. That's actually, it has a lot of different functions. It's not only supports as a listener, but it could be used as for connection also. Like we can directly connect to remote machines if it's going to be a bind shell. So don't confuse with the bind shell. Yeah, definitely I will explain that later videos. So for this I'm just trying this one because the port it is suggested as 8080, and now come here, cargo build, and let us see how it works. Did it create? Oh my god, that is fast. I didn't expect that much, because normally the problem with Rust is, you know, it takes much time to compile. So here oh, it did run. TCP agent. Let us see what happens in this one. Enter. Oh yeah, we got a message here that we did, something connected, and let us see what happens. Oh yeah, it works. Like, see, because it shows in both sides, because we did try to print it in the agent also. That's why we are showing this here. It is the application is printing the message here, and you know, there is no error here. So if you want to see the error, actually you have to say ipconfig. It's a Windows command. So see, suppose imagine if you are not sending the this one, the error to the stream, you don't see this here. It will be a confusing part for you. I'll show you that. So it is basically it is working. So let's try to do it without. Okay, so if it is going to be that case, I have to comment this and this, and now I have to build it again. Now let's see what's the difference in that. Running it again. Oh, it should have a listener. See, now in this case, if I say ls, it will work, but if I say ipconfig, see, you won't get any response back to your controller. Why? Because we didn't send the std error. So it's always good to send the actual output and the error to the controller. Then you will come to know what exactly happened on the agent side, how it works. So this now works as a perfect basic what to say, just comment these two. This is a basic skeleton type of reversal, but we have to improve a lot. Like, you know, now if you listen, we don't have any, you know, it's just like a blank thing that even after the connection. So if you want to, suppose if you want to, after connecting, just for identification, if what you can do is you can write something to the stream, server stream, to make sure that, or not to make sure, actually to indicate that the agent got connected perfectly. So for that, what we can do is we can try the stream dot write what should we write, like yeah, let it be alphas, and this one, yeah, of course it should be as bytes, and either you can unwrap, or so as I always suggest to expect, and just say some valid like failed to send message to server. This may be more like convincing shell. Let me build it here, and actually we are just testing it on the same machine, and the reversal is not going to work exactly like this. I will show you how it is going to work on the real-time machines, like a remote machine. but for the time being we are just confirming the functions that we need to create. See, now I got a message and it says an alpha, so I can confirm that it is. So from here I can send message again. See, you lost the prompt. So what could be done here, we can send the prompt on some other place too. Maybe what if I do another right here, the same right here. I don't know how it's going to work here, but so this is like after sending all the result again, it goes back to the prompt. Just make the prompt a bit tidier. Let us try this again. Build it and listen. Legend plus. Oh yeah, now it works perfectly. Let's see. It is the prompt is working well, and try the error. See, ipconfig is not there in Windows and Linux, so it just sends the error back to us. And you know, the better part here is we are using netcat, and netcat is internally handling a lot of stuff, especially when it handles the new lines on the result perfectly, and yeah, so many things internally it handles. You will come to know how exactly the netcat listener works when you try to develop your own listener. So now this is a perfect example of a reverse shell that works perfectly for Linux. So what if we need to make Windows binaries, like, and what if it's going to how exactly we can do that with the same code base? So for that we need another thing. The concept is called cross-compilation, and I have this for you. Basically it's going to make use of CFG, the Rust configuration mechanism, to handle the cross-compilation. And there are two options for you to make it working. The example is just I just shown here as Windows, but because we are going to make use of the same code base to run Windows reversals also. To make Windows reversals, you have two options here. Either you can make use of this hash CFD Windows option. It's a kind of conditional compilation. So what happens here is it ensures, when you are going to make use of this option, it ensures that the code just after that, the code block just after that, will never get compiled if you are trying to make a Linux binary. So definitely it's going to be an optimized option. Like you don't need to compile the Windows side code when you are making binary for Linux, or vice versa. But if the specialty of this macro, actually, whatever you see with the exclamation mark at the end, like println and print and these kind of things are called macros. So when you're going to use this macro and mention the operating system name inside that, this is going to evaluate to a boolean value at compile time, and it's going to be like a normal if condition. And compared to the other option, what happens here is the code will get compiled and it's going to be added to your binary. So maybe you are increasing your binary size because this code is going to get compiled. It will be in the binary, but definitely you can ensure that this code will get executed only if the binary is going to run on Windows. That's the major difference. The first one will not add that Windows whatever operating system conditional compiler compilation option you have added. It will not get compiled or added to the binary other than the operating system you are targeting. But there are some other things that you need to make. Suppose if you want to build Linux or Windows binaries from Linux machine, you need to do some other steps, like some other extra steps. For that, the first thing you have to ensure is that you have to check what are the other available options in Rust. So you can make use of the rustup tool for that. Rustup target list will give you all the available options that you can add to your current project. So for the filter it, we can use of grep. See, you have all these Windows options available, and you know, I have already added these two into my this machine because I'm just practicing my coding here inside this one. So if you want to add this to your machine like this, what you can do is just mention target add and whatever Windows option you need to add. Then once if you have added this tool chain, the next thing that you have to do is you need a linker for this for making the binary for Windows. So you have to install this one also, because I already did in my machine. I'm not going to do it again, but just keep in mind that these two are very important things that you have to do. Find a version that you need. For me, I'm going to do the x86-64 architecture. Then I have to install this one to make my binary work for me. So I have all these things installed, but what I'm going to do is I have to add this target, this one, to my otherwise I will add from my machine itself. Let's add. What's that? Okay, it's already installed. So see that the difference is going to be here. See here inside under the target, you don't see any extra options. But once if you rustup add target, exactly you can try is here, this one. Syntax different. Rustup target add. Rustup. Oh, I did this different way. It's rustup target then add. So now we have it is there. So now the next thing when I'm trying to compile it is I have to do the compilation in this way. Cargo build hyphen release hyphen target. Then I had to, where is that? Copy here. Again, the syntax, why are the syntax? Cargo build, release. Okay, there are two hyphens on the target too. So it tried to create another one. So if you come here on the target, now we can see there's an extra folder here, and your exe will be created under the release, because I had tried to create it release mode. So it should be here. See, the target, TCP agent.exe is here, but this code will not work in Windows because we haven't changed anything here. We didn't add any compilation, that conditional compilation here. So the next thing we had to add is that. So before that, we had to modify this reverse shell, common stuffs in this reverse shell. As an example, after receiving the command, get the command here, and there are some extra things that you have to do is like if command equal to, exit. You can either break from the loop, or you can send some message before breaking. As an example here, I'm just saying instead of this, I can say connection terminator, something like that, and you can break from the loop. When you're breaking from the loop, actually it is going to the main function and just completely stops the application. So this could be one thing that you can do for this. Next is the big thing that you have to do. So let's try with this one. I forgot the syntax of this one. How it is? It is. If it is going to be like this, I think you don't need this one. This block, let us try to copy this here. So if in case of Windows, either you can try PowerShell or the classic CMD. And it's not this one. I think it is /c. Let's try that, and the remaining things should work. And here just we are going to ensure that this is going to work early on. For Unix family. It's here, right? It should be here, and this is a loop. Let me format this. So we have added, see, it's by default Visual Studio is showing in the Rust analyzer is showing this is disabled. And the best part of this one is this code will never compiled or added to the binary when you are trying to build a Linux binary, and this code will not compile and add it to the binary when you're trying to do a Windows binary. So this ensures that the binary will be optimized, and we can create our own, like it supports the cross compilation with the same set of code, but of course the other way is also good, using the macro. But when you're trying to use the macro, your binary will be having both side of codes. It doesn't exclude your code from the binary. So I think this will, let us try this one. For instead of this, the next thing what I'm going to do is I'm going to make my server as this one, and this is going to be my listener IP. I'm going to add it here and try to make use of some good port, because this application is trying to reach to the listener. If it's going to be a suspicious port, yeah, definitely your reversal will be in danger because it's easy to get noticed. But if it's going to be normal ports, it is highly but definitely anyway, in a big corporate environment with a lot of defensive layers, defensive stack, so it will be difficult to directly get a shell over using TCP. But even in normal cases, try to make use of ports like 443 to ensure that you are not making any normal basic mistakes. So now I change to my server side, and okay, no, not for, okay, yeah, it should be. No, I think better I can try to make it here itself. Oops. I can make it this IP and 199, and instead of the previous command that we did, we will make cut 443. Oh, it's already running. Or it's already in use, I don't know. In that case, if you can, okay, it's permission of that port. So now this is running, the listener is running, and we are going to make compile our binary again for Windows. Let me try it again. Now I have a Windows binary, target CD. I did do it in release mode, so if I do analysis here, you can see an .exe here. So now what I'm going to test it in another machine. Let me see my machine is ready or not. I had another machine. Yeah, I'm going to do it here. Let me transfer this to my sudo cp agent.exe to where we are view HTML. Hope it is there. Sudo service passion to status. It's running. So it's 199, and let me try to download it there. Maybe it will because I'm expecting a block from yeah, it works. TCP agent.exe Defender didn't remove it. Okay, I can directly open that, but let me, for the sake of CD downloads, and the name is TCP agent. If everything works well, this will work. It didn't have any issue till now, so let's come to see. Here we got here, if you say ls, it won't work because ls is not a command in Windows. But if you say dir, it will work. And who am I? Yeah, it perfectly worked. It doesn't have any issue. So just configure. These commands we tried on previous time because the other one was in Linux. See, this is a way we can develop an agent completely using Rust. So I think we did a bit different way compared to the one I have in my GitHub. Let me see how it was. I did a long time before. So yeah, in that actually I did both Rust agent and controller. It was a custom controller, but that controller had some issues at that time, but it was working. But still it was not an optimized controller. Let me see how I did in. Yeah, these things are almost same. The main difference is here. There at that time I was using the CFG macro, not the conditional compiler. What is the name of the decorations? I don't know. It's hash CFG option. And other difference is, yeah, there is no exit. Oh, we didn't check the exit. Let me see how gracefully it is exiting. Oh, it didn't exit. Maybe because I'm okay. I think if you want to check exactly, because when we are entering it, I think it sends with the ender. So there will be some slash lines. I mean slash new lines trim. I think trim end is the command that will help us to do that. It automatically removes the slash ends. It returns a single slide trailing white space removed, definitely according to the Unicode white space, which includes new lines. Yeah, this will remove the new lines also. For that, again, I'm not going to test it, but I'm going to test this in here. Or do I need to test it there? No, I don't want to make it this one a long video, so I'm just exiting from here and start our listener again and come here and TCP target here is cargo bill. Okay, let us TCP cd debug / TCP agent. Let's try that exit function here itself. Let's exit. Oh yeah, we got this message because we did. Now actually this is your machine, so we have to set a new line here also, then it will be fine. See, the exit was not working previously because we didn't trim the new lines and extra white spaces. If we normally the new lines comes with this one, but if we add some extra white spaces, that also get removed using the trim end command. Then now it works perfectly. I don't know, something else that we can add, you can think of that. But now at present in this video we haven't used any custom listener or controller, so already I have loaded the code for that. If you are interested in that, you can check that, but there is an issue in that. There's a latency in getting commands result in the current controller, but definitely we can optimize that. If you are interested, you can go and check and develop your own custom controller based on that. Or yeah, I mean, when you have more the custom controller. Like when we use netcat as a listener or controller, the issue is that we don't get any advanced options. Like here I can just run only any, what to say, only, that cmd allowed commands. Definitely cmd will allow to do any commands with the limitation is the user permission, current user permission. But suppose if you have a custom listener, then maybe you can add some more functions to your agent, like taking screenshots of the victim and then sends back to the controller. Then the controller can save that to your local listener, somewhere, and you can save that, and maybe you can try starting some keylogger on the agent, and then the agent will send back all the keylog to back to the listener. Those kind of stuff you can add additionally. That is not supported by the netcat. So this was a very basic thing. Like I just wanted to show how we can start something from the scratch, like developing a new reversal agent, and definitely it has a lot of more expansion options. So it's up to you if you are interested in Rust, and if you want to learn more on Rust, you can try that. For this video I'm stopping this here because we did the basic stuff. So we are going to continue on the reversals options and other networking options that we can make use of while we do network related activities in pentesting or any red team activities. The main aim here is just to try to learn more Rust, try to be familiar with Rust, and so focus on Rust and try to focus on making cybersecurity related tools. If you are into cybersecurity, even if you are not into cybersecurity, you can try these kind of tools, so you will get more familiar with security plus coding. So that's the main thing. I started developing this series focusing on cybersecurity. I think I did cover everything I planned for. This one, yeah, thread I have covered last time. So that's all for this video. See you soon with another interesting Rust project. Till then, it's a bye from Alphas.